back to A-Level Lessons Online. Okay, we're finally reaching the end of this journey of our 2017 Paper 1. Okay, H2 Math Paper 1. It has been quite a crazy yet fun paper to do. Okay, but we're finally coming to an end of this Paper 1 before we move on to Paper 2, which is going to be a lot more on statistics and all. This question that we're ending off is going to be on differential equations, okay, which is a very, very fun topic, okay, if you get a hang of it, because every question is always the same. Okay, only the context changes. So once you get a hang of the context and you know what the question is asking, the rate of change, rate of everything in differential equations is always going to be the same. Alright, so let's go through it slowly as we end off this very, very wonderful series, okay, on our paper 1. Alright, so Sir Isaac Newton, wow, we are starting off with a science question. For ending off with a science question. Amazing. Okay, so he states that for his whatever laws of motion, okay, I'm not a huge fan of physics. Okay, one law states that for an object falling vertically in a vacuum, the rate of change, velocity v, okay, with respect to t is constant c. So right now, a differential equation relating vt and c. This is one of the easiest questions I think you would ever see in the paper. So part 1 is very simply, okay, they say that the rate of change of v with in relation to time is c. Your answer is just dv over dt equals to c. That is all. Okay, part 1, very, very simple. This is what, A, is it? Yeah, A. Part 1a. Okay, part B. Initially, the velocity of the object is 4 meters per second, and after a further 2.5 seconds, so initially, highlight the words, and further 2.5, the velocity of the object is 29 meters per second. So find v in terms of t and state the value of c. This is also very easy. Over here, what we're going to do is we're going to do a bit of integration, alright? So for part B, it gives you that velocity is, dv dt is equals to c. So how do we find velocity? Is we integrate this equation with respect to t. So you integrate c dt. So c dt take c, take it like you're integrating something with respect to x. Okay, so c will just become ct plus a constant. So let's just use a, for instance. Okay, so firstly, they ask you initially. So initially would be when t equals to 0. So when t equals to 0, your velocity equals to 4. So 4 equals to c times 0 plus a. So you can find a is equals to 4. Easy. Alright, then after that they say when t equals to 2.5 seconds, your velocity is 29 meters per second. So you just need to sub this in. You will simply get velocity, which is 29, equals to c times 2.5 plus 4. You will find that your c will just very simply be a very nice value of 10. Okay, so therefore you can come up with the equation of your velocity, which is that v equals to 10t plus 4. Simple. Okay, so that is part 1 done. It's a very simple question. Okay, part B, for an object falling vertically, the rate of change of velocity is less than that of an object falling in a vacuum. The new rate of change v is modeled by the difference, okay, the difference between the value of c found in this part B, part 1, part B, and an amount proportional to the velocity v with a constant of proportionality k. Okay, so they give us the constant of proportionality. That is what we're looking out for. So given that this case, the initial velocity is 0, find v in terms of t and k. Alright, very easy part as well, right? So it already gave us the constant of proportionality, which is k. So we're just going to write out our new velocity equation, which is dv over dt would now be equivalent to 10, the difference, minus k, constant of proportionality, velocity. Okay, because over here it says that it is the difference between the value found in the value of c, which we found is 10, okay, and the amount proportional to velocity v with a constant of proportionality v. Okay, so over here is where you can start to apply your differential equations, okay, what you've learned in differential equations, which would be to cross the things over. So over here is essentially saying that this whole part is like this, and that there is a 1 for the time t. So this is what we have learned all along in our differential equations since young, right? So just bring over the correct side to the other. You will have 1 over 10 minus kv dv dt equals to 1. So integrate the whole thing now. You will just integrate 1 over 10 minus kv dv equals to integrate 1 dt. So integrating 1 of dt, you'll just be left with t. On this side, it is your classic ln formula. So it'll be negative 1 over k because you differentiate the bottom. You bring it on top, then you have ln mod 10 minus kv. This will be equals to t, and always remember your constant. In this case, we use b. Alright, so now that this part is done, we can start to get rid of certain things. Okay, so let's multiply everything by k. To get rid of the k, you get ln 10 minus kv, mod the whole thing, you will get minus kt minus kb. Okay, after this, let's start to transform it a little so we can exponential the other side so that you'll be left with 10 minus kv, and you will have plus minus k, because remember, every time you unmod something, there will be a plus minus. Then you get e to the power of minus kt, e to the power of minus kb. Okay, so usually we split it up for exponential, right? We can split the minus kt, and we can split because of your rule of exponential is that when you combine the two, this is the rule of indices, right? When you combine it, it will just be minus kt minus plus the minus kb, so it will be the same thing. I'm talking about top. Okay, so now all you can do is you can move more of it to one side, but before that, we can let another constant d be equivalent to minus k, e to the power minus kb, since all three of them, e, k, and b, are all constants. So therefore 10 minus kv will just give us d plus minus d, and then e to the power of minus kt. Okay, so once we're at this step, one more thing we can do is to actually get rid of the plus minus, and we can shift the plus minus to your constant d as well. So therefore, if we shift it to over here, plus minus, it will just be 10 minus kv equals to d. So it's now absorbed into the d equals to d e to the power of minus kt. Done. Okay, so now let's just leave your velocity on one side. So if you leave it on one side, you just have v equals to 1 over k times 10 minus d e to the power of minus kt. So this is a method, this is very simple, bring over to one side and all. So now is where we can let t equals to 0, because that was what the question gave. So therefore, when time equals to 0, 1 over k times 10 minus d, because everything e to the power of 0 would just be 1. So 10 minus d would now be equals to 0. So you can 1 over k is a constant, so you can just get rid of it. So you just get d equals to 10. So therefore, you can then write your answer, which is therefore v equals to 1 over k, a constant, times 10 minus 10 e to the power of minus kt, and that would be your answer solved. Okay, very simple part to part 2. Okay, the last part, part 3, is the part that you always see in every type of question, differential equation. Okay, terminal velocity, okay, whereby the initial velocity is 0 and terminal velocity is at 40 meters per second. So how long does it take for the object to reach 90% of its terminal velocity? So terminal velocity is 40, so over here, for 90% will be 0 times 0.9 times 40 to find what the 90% is. So let's do part 3 real quick. It's very easy. So when your t, in this case terminal velocity is when t tends to infinity. Okay, that means your time tends to infinity. What happens is that your velocity will also tend towards 10 over k. This is from previously, right? This is if I take out the 10, sorry. I think a lot of you may be lost over here. Okay, let me just use the previous one over here. Okay, so v equals to 1 over k, 10 minus 10 e to the power minus kt. So what I can do over here is I can actually take out the 10. I'll get 10 over k times 1 minus e to the power minus kt. Okay, so therefore when t tends towards infinity, v would tend towards 10 over k times 1 minus 0, because e to the power of infinity would then make the whole thing 0. So this would just be equivalent to 10 over k. So what you can do is that since this is when it tends towards terminal velocity, 10 over k would then be equivalent to 40. So k would then be 1 over 4. So therefore, you can now find the velocity, your equation of the velocity, which is v is 10 minus 10 e to the power of minus kt, right? So minus t over 4. Okay, so now you will want to let v equals to your 0.9 times 40, because this is when it's at 90%, right? So how long does it take for the object to reach 90%? So now we're finding the time. So you're going to let the velocity be equivalent to this, which is 36. So 4 times 10 minus 10e to the power of minus t over 4 will be equivalent to 36. So bring all the numbers to one side, you'll be left with e to the power minus t over 4 equals to 1 over 10. So after that, you can ln the other side. You get minus t over 4 equals to ln 1 over 10. So just press all of this in the calculator. You will simply get t equals to 9.2103, which you can round it off to 9.21, always 2 decimal place because it is in seconds, 9.21 seconds. So that will be our answer. So for it to reach 90% of its terminal velocity, it would take 9.21 seconds. Okay, so that's all for this question. So it's a very simple rate of change and differential equation question, not the hardest. You always find that all these questions, okay, as we explore more of your other A-level papers, you'll find that a lot of them tend to have the last part whereby it's something tending towards infinity. Your time is always tending towards infinity. So this is a very classic question, not extremely hard, and I think it's a good way to end off the paper because it's not the hardest question, but at the same time, some students will not be able to do it as well. So make sure you're able to do this kind of question. Okay, if you have any questions, leave it in the comment section below. I will answer them as soon as possible. This will mark the end of our paper 1. So after this, we'll be moving on to our paper 2 of 2017. Our 2017 paper. After that, we may go over to 2018 paper or either that to 2016 paper. We'll see how. So if you did enjoy this video, okay, do give it a like. It really does help me out a lot. As well as to subscribe to the channel, okay, so that you can be up to date with when I'll be releasing more math videos. So very soon also I'll be starting our topical series, okay, so things like going through everything you need to know about vectors, everything you need to know about differential equations. I'll be covering that very soon as well. So not to worry if you're still a bit lost, okay, just keep on practicing, okay. Math is about practice. You need to practice a lot of questions to understand what the topics are asking you for. Okay, so if not, I'll see you guys in the next one. Till then, have a good one. Bye bye.